Hello and welcome to today's session. I'm Melanie Mingus, Deputy Editor at Capacity Magazine, and you are watching the latest innovations in subsea fibre optics and the Malbec cable system. Today's session is brought to you by GlobeNet, and presenting for us over the next hour, please welcome Philippe Perrier, CTO of GlobeNet, Diana Perez, the Carrier Sales Manager, also from GlobeNet, and Richard Nilsson, Marketing Director for the Americas region at Alcatel Submarine Networks. Now, despite the economic challenges emerging around the world this year, the subsea industry has come into its own, and now even people beyond the telecoms industry has an understanding of subsea cables. In South America, GlobeNet's Malbec system, which connects Argentina to Brazil, is one of three major projects to go into service in the second half of this year. The cable was built in Calais, France by Alcatel Submarine Networks and will offer latencies between 108 milliseconds between New York and Sao Paulo and sub-78 milliseconds between New York and Bogota. Over the course of this session, we are going to hear about the Malbec system from those who built it, and at the end of the session, audience members will have an opportunity to direct questions to the speakers. But without any further delay, I'm delighted to hand over now to Diana Perez, who's going to tell us more about GlobeNet and this project.
Thank you, Melanie. And thanks to Capacity Media for this platform and the 2020 Global Carrier Award for Best Subsea Innovation. I'd like to give you a brief overview of the current state of the subsea cable systems in Latin America to provide context on Malbec and what it represents to Argentina and the region. Over the course of the last decade, wholesale carriers, both subsea and terrestrial, have made significant investments in infrastructure in Latin America that is a continuum of digital transformation for the region. New routes and expansion of capacity to existing systems has been steadily observed. Also, interregional and intercontinental connectivity has become very important given the interaction between users in neighboring countries. The major investments, though, over the last decade or so have been to reinforce the existing Atlantic routes to major markets, for example, Brazil, and improve connectivity in Pacific routes. An interesting observation in the recent participation of large OTTs in co-ownerships and builds similar to the situation with Facebook and GlobeNet and Malbec. Demand is driving not only the need for greater capacity, but also lower latency and security. In this context, we can reference the landing of Malbec to Argentina. It is the first subsea system to land in Argentina in nearly 20 years. Not only the subsea network, but also the terrestrial infrastructure and the integration to larger intercontinental subsea systems will add significant improvements to Argentina's economy and technological growth. Now, I know we're here to talk about Malbec, but this system is part of a larger network that GlobeNet owns and operates, which I'd like to touch on briefly. GlobeNet has been a leader in the wholesale carrier services market for over 15 years. Our cable system has served the US, Brazil, Colombia, Venezuela, and Bermuda markets with a carrier-neutral approach to business. The extension to Argentina is a natural fit for a network that overall will span more than 26,000 kilometers upon completion of Malbec. Our backbone is designed to support 100 gig and 400 gig capacity with a broad offering of services. Across our backbone and focused on our wholesale business, we offer solutions in the major cities and POPs our customers can leverage. The baseline service is our transport, solutions such as wavelength and Ethernet. Adding to the stack is our IP products, infrastructure as a service like colocation and virtualization services, again focused on our core business and located in the major data centers, POPs, and landing stations. And lastly, our security solution suite that today is much more important to mitigate DDoS attacks and secure the network. So why Malbec and how does it fit into our existing network? In considering Argentina, it is the furthest most country in the South Atlantic and the second largest national economy in South America. Being the southernmost country in South America, investments for a cable connecting the large sources of content coming from the US and Europe is very costly and very labor intensive. We are in a unique position as a provider of services in proximity to Argentina with a proprietary network to build an extension that is integrated to its own subsea system in a seamless manner. GlobeNet's long-dated presence in Brazil and the understanding of the Argentinian market gives us the possibility to increase and enhance the product and service offerings to the region. You can see here how Malbec integrates into our existing network. The most southern landing station was previously in Rio. The addition of Malbec takes our network south to a landing station in Praia Grande that connects us via subsea routes between Rio and São Paulo, and adds a new major POP in SP4 as well as Tivit. This is key as it allows us to avoid the major pitfalls of cable cuts over terrestrial paths in the Rio-São Paulo route. From Praia Grande, we connect a new landing station in Las Toninas, Argentina, and extend protected terrestrial backhauls to 2 new POPs in Argentina, Pacheco and Artigas. You will hear more details on the design from Philippe and Richard coming up. A few critical requirements of the Malbec design were capacity, diversity, resiliency, and the reduction of latency. Like I touched on earlier in the introduction, these are all key elements that are demanded by digital transformation. Philippe will detail how these elements align with the design. However, I wanted to emphasize latency briefly. The estimated latency in the Malbec subsea network is 26.7 milliseconds between SP4 and Pacheco, and 108 milliseconds in the legacy network from Brazil to New York. The pandemic has accelerated the need to leverage high-speed networks to reach users and deliver content, especially with live streaming, gaming, etc. High video latency is caused by delays in the delivery path, which kills the live video experience for users, especially considering live sporting events, gaming, and very necessary live news updates. So the 3 to 4 milliseconds improvement Malbec offers makes a world of difference for OTT live streaming video services. With Argentina as a major market in Latin America, it is key for North American providers to use the most reliable and resilient networks to access the region. I will now pass the presentation to Philippe, who will give you the design and technical details of the system.
Thank you, Diana. So the Malbec cable system is extending GlobeNet's existing subsea network into Argentina, as explained by Diana. It is a co-built with Facebook, with GlobeNet being the developer and the operator of the cable system. ASN was selected to deliver the cable system as a turnkey project. So the Malbec cable system was designed considering several requirements that we deem were must-haves for the current and future market demands. One of these requirements was, of course, large capacity in order to address the current and future demands from high traffic applications like streaming, cloud, gaming, and more generally, OTT traffic. Most of the international cable system landing in Argentina today, by the way, most of them in Las Toninas, are nearing their end of life. They were deployed about two decades ago, and will be decommissioned or have run out of capacity. The Malbec cable system will more than double the total capacity that is currently available between Argentina and Brazil and the US. A second requisite was diversity from existing routes and infrastructure to meet the need for multiple accesses to POPs or data centers. Another requirement was resiliency in order to support mission-critical applications such as cloud and corporate traffic. And I will go over in more details about the several layers of resiliency that we implemented. Finally, low latency for cloud and gaming application mainly. So as you can see on this slide, the Malbec cable system connects our existing CLS cable landing station in Rio de Janeiro to a new cable landing station in Las Toninas in Argentina. A branching unit allows to connect the Rio and Las Toninas cable landing station to another new cable landing station in Praia Grande, not far from São Paulo. As mentioned before, we decided to build a new cable landing station in both Praia Grande and Las Toninas to provide diversity from existing infrastructure at both locations. As you can see, also, the cable is equipped with a stub branching unit in prevision of a future landing in the south of Brazil. The trunk cable between Rio and Las Toninas consists of 6 fiber pairs, and the branch to Praia Grande of 8 fiber pairs. 5 fiber pairs connecting to Rio and 3 fiber pairs connecting to Las Toninas. And the cable was designed for a minimum capacity of 18 terabit per fiber, so for a total of capacity of 108 terabit between Rio and Las Toninas. The Malbec cable system makes use of the latest advancement in subsea technologies. As an example, it was designed as an open cable system. An open cable system decouples the wet plant from the transmission equipment, also referred as a submarine line terminal equipment. And it does give an operator the flexibility to select submarine line terminal equipments from any suppliers. And this is a key parameter in the sense that the technology or advancements in transponder technology have a fast turnaround. So it is possible to change the technology of the SLTE to the SLTE very often, or as a new generation of transponders come on the market, without being tied to the design of the wet plant. The cable system design also relies on a spatial division multiplexing. This is a scheme which looks at maximizing the capacity of the cable rather than the capacity per fiber. Another example of the advancement in subsea technologies is the use of the latest generation of repeaters, branching units, and monitoring that lead to an even more reliable cable system. Additional resiliency is provided by a careful selection of the cable route. For instance, the route was developed for the cable to reach deep water, where the occurrence of a cable break is less likely, as quickly as possible. It is also provided by or additional resiliency is also provided by a careful selection of the cable armoring and by burial of the cable to extreme depth, way past the typical 1,500 meters water depth in areas of heavy fishing activities. Rick will expand on some of these new technologies shortly.
Philippe, I would like to also just add that the stub BU that you mentioned in the previous slide is also configured to allow the inclusion of the latest generation ASN wavelength selectable switch that would provide wavelength routing between stations all the way down to specific channel level.
Thank you, Rick. It's a good opportunity to mention that with the ROADM BU, routing can be done at the wavelength level, not at the fiber level. So, yeah, thank you for this precision. The requirements considered for the design of the Malbec subsea cable system that I presented on the previous slide also apply to the entire Malbec network. By a Malbec network, I mean not only the Malbec subsea cable system, but also the terrestrial systems or backhauls interconnecting the cable landing station to the point of presence. So in Brazil, the backhaul connects the Praia Grande CLS to the TV data center and the Equinix SP4 data center in São Paulo. A separate system connects SP4 to an existing point of presence at SP2. In Argentina, the backhaul connects the Las Toninas cable landing station to the Lumen data center at Artegas and to the Telecom Argentina data center at Pacheco. The distributed SLTs are located at the POPs, not at the Praia Grande or Las Toninas CLS, as you might find in older generation submarine cable system. And the terrestrial backhauls are seamlessly integrated with the subsea cable system, providing an additional level of resiliency because you have less equipment now at the cable landing station. The latest generation of coherent transponders capable of up to 800 gig per wavelength are being deployed. And for example, the longest digital line system between SP4 and Pacheco, close to 2,800 kilometers long, can support 400G wavelengths end-to-end. Higher rates wavelengths are supported on the shorter digital line system, like between Rio and SP4, or Rio and Buenos Aires. Now, if you look carefully, you will see that the Malbec network is architected as a concatenation of 4 rings. If you can see my pointer here, redundancy of the submarine connectivity between the CLS is provided by diverse submarine cable system. So you have a first ring, submarine ring. You have a second submarine ring between Praia Grande and Las Toninas. The first ring is between Praia Grande and Rio. And then you have redundant, geographically diverse backhauls from the cable landing station to the POPs, making up rings number 3 and number 4. Now, protection or restoration schemes at layer 0, which is the optical layer, is available end-to-end or by domain. And by domain, I mean at the ring level. So, for instance, you could have a protection, optical protection between Pacheco and Rio, for instance. So if you have a cable break, for instance, on the Malbec system between Las Toninas and Rio, the protection, the optical protection will take place at Las Toninas, where the traffic will be routed through Praia Grande back to Rio. Okay, but the same protection or restoration scheme can also take place at the domain level, meaning at the ring. So, for instance, if you have a cable cut between Pacheco and Las Toninas, you don't have to protect end-to-end. You can just protect the traffic going from Pacheco to Las Toninas via the protect route, or the protect route, the second route of the backhaul between Pacheco and Las Toninas. So the protection will be restricted to this domain here, and will not need to take place over the entire system. And this capability is achieved through reconfigurable optical add-drop multiplexers, which are located at the cable landing station as well as at the POPs. Now, as a final note, Malbec is fully integrated to the existing GlobeNet network, meaning that it is operated and managed by the same operations team and by the same NOC as our existing system. Now, I realize that I just gave you a lot of information in a short period of time. So if anything, I would like you to take away from these 2 slides that though it is a short system, the Malbec system is relying on a sophisticated design, state-of-the-art technologies, both subsea and transmission, is robust and will be able to serve markets and customer currents and future demands. Back to you, Melanie.
Thank you so much, and thank you to everybody else. Now turning to Richard Nilsson from Alcatel Submarine Networks. Alcatel built system, but Richard, tell us more about Alcatel's participation in the Malbec cable construction.
It would be my pleasure. Alcatel Submarine Networks, a global leader in the submarine telecommunications market, is honored to be deploying a high-performance subsea system between Brazil and Argentina for GlobeNet, a long-standing customer in the region. And just as a good Malbec wine is based on a three-pillar foundation of soil, climate, and harvesting time, the ASN Malbec solution is based on a foundation of the following three pillars that you see on the left-hand side of the slide. State-of-the-art technology and products to deliver superior performance, the mastering of an end-to-end integrated project solution, and finally, the knowledge of the local environment and the support from local partners. In terms of technology and products, the ASN solution is based on a unique combination of 170 years of experience dating back to the 1850s and the most recent technology innovations that include our field-proven OLC4 cable that has been deployed throughout the globe during the last 20 years, totaling more than 650,000 kilometers. Our leading edge SDM1 or spatial division multiplexing first step design has been promoted in recent years to offer increased capacity at the best cost per bit, together with maximum submerged plant reliability. One example is our innovative pump farming feature within the Malbec repeaters that provide maximum reliability at a lower cost. And finally, our open network solution has been developed to offer submarine cable operators full flexibility in the design and selection of their transmission solution that allows easy extension of the network beyond the cable landing station to the POP or data center.
Rick, coming back to the SDM, it's a concept, in fact, which or approach, as you mentioned, that encompasses a lot of things. It can encompasses not only the repeaters, as you mentioned, and the pumping scheme, but it also involves like the fiber type, and it has a lot of repercussion on the design of the system as well. So you need, for instance, less total output pump power of the repeaters. All of that combined to reduce, in fact, the cost of the system per bit, or optimize the cost per bit.
Exactly. It's a holistic approach that we're taking. We're looking at this on a total cable level and not just an individual fiber level. So what we're trying to accomplish here is to give you the best performance at the best cost by looking at not necessarily putting the most premium grade of materials and elements in, but putting in the necessary amount, looking at it from a total cable perspective to give you the maximum performance at the lowest cost per bit. So ASN has delivered for Malbec a fully integrated turnkey solution, ensuring a smooth implementation. The marine installation has been performed by our powerful ILDA-class vessels with support from proven marine subcontractors. Expandable cable landing stations and full land route civil works construction were part of the delivery and fully integrated in the design and deployment program. Permitting was managed by ASN teams in close cooperation with Marine and GlobeNet teams. And obviously, the unexpected had to be carefully managed as the COVID-19 pandemic generated significant challenges for all of the teams. One example of this is the impact of closing the ports in Brazil and Argentina during the marine installation program that caused us to find another cable port that was open, that was 1,000 kilometers away, in order to perform both personnel transfer and cable transfer activities. While the ASN project team is continuously working on subsea projects around the globe, the Malbec project success would not have been possible without local experience and a network of local partners. Such experience has been built across the years thanks to a diverse set of projects in South America, where ASN is #1 in the region. The marine experience from these projects enables our team to select the best cable route possible. And as previously mentioned by Philippe, this includes ultra-deep burial and special heavy armor cable protection in certain areas of high risk. Local partners have been involved in every step of the project, and this includes the permitting in all countries, CLS and civil works construction and installation in both Argentina and Brazil, and equipment installation and testing. The result of our focus on these 3 pillars is a best-in-breed Malbec submarine cable network, enabling GlobeNet to take big step ahead in terms of connectivity in the region. This is thanks to our SDM1 design that provides future-proof pop-to-pop capacity between Rio, Sao Paulo, and Buenos Aires. It ensures minimum latency thanks to its direct routing. It ensures maximum resilience thanks to ASN products and optimized route protection. And with that, I'd like to now share a few slides of the actual deployment of the Malbec system. So this first slide shows the beginning of the Rio shore end activity. The cable lay vessel, in this particular case, the CS recorder, is stationed off of Rio. For those of you who have really good vision, you can see a small landing craft to the right of the vessel along with an orange buoy string. It's going toward the shore there.
So yes, the small vessel is pulling the cable, which is buoyed to which is suspended from the buoys, and it's pulling the cable toward the shore.
Yeah, here is a different perspective. This slide shows the cable that's now fully floated to the beach in Rio. The buoys are used to keep the cable near the surface of the water during the float-in process. Once the full length of cable has been pulled to the shore, the buoys are removed, and the cable then sinks to the seabed and is buried with diver jetting tools. Philippe, you want to add anything further? We can go to the next landing.
Yeah, we can go to the next landing.
Okay, so here is a very similar landing in Praia Grande. You can see the cable vessel. In this particular case, it's also the CS recorder. We use the CS recorder for the Brazilian activities on this project. And you see the cable being floated in with the buoys.
Yes, in this particular landing, you can see that the ship is much further away from the beach than in the Rio landing, and that's because you have a long shallow water in Praia Grande, longer than in Rio. So the ship cannot get too close from the beach.
Yeah, you see the cable also going around the quadrant there. That's actually kept in place by the bucket of the backhoe. Also, I'd like to point out one of the proud traditions that ASN is pleased to continue on the Malbec project is the commemorative golden buoy. That celebrates the cable landing at each of the 3 Malbec locations. ASN is very proud to add these 3 golden buoys to an ever-growing collection that GlobeNet has in their network. So now we're at Los Dinos. You notice that the ship is a little bit different. In this particular case, it is the Peter Faber. What I will say is that the Peter Faber did the shore end activities in Los Dinos. The bulk of the main lay activities were performed by the Ilda Seine, which is one of ASN's powerful Ilda class vessels. In this particular case, you also see the cable coming off and going toward the Los Toninas shore, where the cable is then terminated. So once it's at the beach, there's a number of activities that occur when it's on the beach. This slide shows the beach activities in Los Toninas, but it's similar to all of the other beaches. So it includes building the beach manhole, and that creates the transition between the submarine cable and the land cable going to the CLS, as well as creating a grounding bed that is part of the powering circuit for the subsea repeaters and the BUs. One thing that I'd also like to point out, that in some cases we also had to overcome some obstacles along the way. In Praia Grande, we actually went to an ultra deep beach burial in order to go under an existing sewer pipe that was there. So now, oops.
Sorry, yeah. Okay, so these are the photos of the two new CLSs that we built for diversity, as mentioned before. On the left-hand side, you have a view of the Las Toninas CLS, and Praia Grande is depicted on the right-hand side of the slide. The CLS do perform the same task as a conventional or older generation cable landing station, but they are much more compact thanks to the fact that the transmission equipment is more compact than older generation system. But as in a classical cable landing station, both landing station in Las Toninas and Praia Grande consist of terminal rooms, where, for instance, the fiber gateway, which is the interface between the wet plant and the dry plant from potentially another supplier, is located. It also includes power rooms, where you will find like the batteries, the DC plant, and the UPS or AC plant, as well as some storage facility and a control room. It was both CLS were architected for resiliency, so it has a two-end protection. So, for instance, you have like two generators. You have two battery plants associated with a DC plant, as well as a UPS. So for full redundancy, not only at the power level, but also at the cooling for the HVAC unit. I don't know if you have anything to add, Rick.
No.
Okay.
Obviously, we used a large number of local contractors to help support this project and build these two CLSs. Obviously, we had to follow all of the necessary ordinances and requirements associated with placing the units where they were, and you can see some of the protection elements that are put in as well in some of the pictures.
Yep. Back to you, Melanie.
Thank you. Thank you, Richard and Philippe, for sharing that insight. Some great project images there. Now, Diana, bringing you back into the conversation, could you please explain how this new infrastructure is intended to benefit customers?
Thank you, Melanie, of course. Let's look at what services will be supported for Argentina. As noted earlier, the new cable system integrates with the existing network, so protected connectivity from Argentina to the US are available in wavelengths ranging in capacities from 10 gig, 100 gig, and segments up to 400 gigs in capacity. Carrier-grade Ethernet that has dedicated network resources, no oversubscription, and guaranteed protected bandwidth is also available. IPO and EPO services between Rio CLS or SP4 to Argentina will be offered with the newest technology using OTN. These connectivity solutions can be leased with ultra-low latency speeds and latency guarantee. Solutions can be designed by our sales engineering team to offer diversity to other terrestrial and also submarine networks. Lastly, managed spectrum as well as shared spectrum will be available for customers with the need of high capacity. Rapidly scalable IP transit leveraging GlobeNet's ASN can also be leased with committed data rates and optional bursts, as well as zero commit pay for use dynamic bandwidth. This is very important for our local market for our carriers, ISPs, and OTTs. We also have our products like GNX. That's via a layer 2 connection, we extend a tunnel to major global internet exchange points, giving customers access to content and the ability to advertise routes. This product puts our customers in the driver's seat to manage their own global connectivity and peering arrangements at major peering locations without CapEx or equipment costs and co-location costs. Under the IP product family, we also have Cloud Connect. Cloud Connect gives us a secure and private connection to the major providers, such as Google, Microsoft Azure, AWS, Oracle, and IBM, but also to SaaS platforms or other web-based applications. Ports are highly scalable across all clouds and offer the security necessary to protect your network and data. Rounding out the product offerings are Virtual Router and our layered security DDoS solution. Virtual Router is a service for customers that want to take advantage of expanding their network without the expense of hardware or related network assets. This is a service for carriers and ISPs looking to extend beyond domestic markets. It's agile, flexible, and cost-effective, but still allows customers to manage their own network architecture. Finally, DDoS Guard helps carriers and ISPs in Latin America to protect their customers' critical infrastructure against malicious activities and to guarantee network performance without experiencing any form of downtime. On-demand and unlimited service options are available for scrubbing traffic. As important as our network is our support team. We have redundant state-of-the-art NOCs in Buenos Aires and Rio. We offer 24/7, 365-day support from engineering, technical, and regional operations teams to keep your business running. GlobeNet's NOC is staffed with highly trained multilingual technicians who can offer support in English, Spanish, and Portuguese. With round-the-clock NOC services, we help our customers reduce downtime and keep the network running. For our customers in North America that may not have on-site support, our team is available to provide remote and smart hand services in the region. Finally, in summary, the expansion of the GlobeNet network into Argentina will provide our customers higher capacity, lower latency connectivity to meet the growing market demand in Latin America. With new technology and best-in-class support, customers can scale their network quickly and more efficiently. After decades of limited cable systems to Argentina, GlobeNet is proud to be near completion of Malbec and to bring innovation and technology and speed to the network in the region. With the resiliency in the design, our customers can rely on diverse routes and landing stations to build a higher available service offering to their customers. As Philippe detailed earlier, the diversity extends to the backhauls as well as providing pop-to-pop solutions, not just between landing stations. The fully integrated service portfolio for Argentina will allow for seamless expansion of connectivity and value-added solutions across our network, down to Buenos Aires and surrounding areas. We have expanded the GlobeNet team to include commercial and operations support in Argentina as well. Our team continues to grow and expand with our network to support our customers' business needs. As a single point of contact, our NOC Operations Center is available for customers around the clock. From New York to Buenos Aires, our team and network is set to support your needs and to extend your reach into Latin America. Now, I promised the team I would not make a sales pitch, but I would not be doing my job if I didn't let you know that as we wrap up the commissioning of this new system, we do have provisions in place for anyone that needs immediate connectivity to Latin America and to Argentina. Thank you again for your time. We'll return to our host for a brief question and answer session.
You're on mute, Melanie.
There we go. Triple quote. Thank you so much, Diana. Now, we've received a lot of questions over the course of this session. For those who are watching live, you can post any questions that you may have to our speakers using the chat functions that you see on screen. To start addressing some of those questions now, Philippe, we're going to start with a question that's coming for you. One of our audience members would like to know, what has been the impact of COVID-19 on GlobeNet as a whole, and how have you maintained business continuity during this time?
Yes, so as most network operators, we have seen a huge uptick in demand for IP traffic as well as for capacity. We were lucky that we had just completed in 2019, at the end of 2019, a major upgrade of our IP network and as well as our DWDM network or subsea network. So we were able to respond very quickly to demand for additional capacity or IP traffic throughout our network, both in Brazil, also in Colombia. We saw a very large uptick out of Colombia, and in the US as well.
And now another question that's just coming in now for Diana. Huge trend this year is gaming. And the question from the audience member is that as gaming increases data demands, particularly since the global lockdown, do you see this trend affecting the subsea cable market?
Thank you, Melanie. Yes, of course, that's a great question. Well, we already talked about latency and capacity being key in helping the region, especially in live sporting events, anything that's dynamic in nature. Malbec is assisting in that, of course, because we're building a network that is going to guarantee more capacity and lower latency for Argentina. But also in general, as far as gaming is concerned, and the uptick in gaming through the pandemic, one of the key things is to bring together ISPs and content, right? So we host an exchange in the northeast of Brazil in Fortaleza that has over 280 peers, as well as a number of content providers. And there alone, we're helping get the content closer to the users. So overall, yes, we do see it being key for GlobeNet, and we're doing our part.
Excellent. And now another question that's just come in for Philippe. What does the OTT cable initiative represent for the sector?
So if our audience has followed a little bit the subsea industry, the OTTs have been disrupting, I would say, the industry. They started by participating in the build of many subsea cable systems, and now are even building system just for their application. But in our case, Facebook has been a great partner to build this cable system. And I think we'll continue to be, and OTTs will continue to be great partners for other network operators.
Excellent. Thank you, Philippe. And now another question for you as well. What's the lifetime of a subsea system, and how do you update them with new technologies?
Okay, so the typically a subsea cable system is designed for 25 years. And during the life of the system, so it is designed for, I would say, a design capacity. But this design capacity can change during the life of the system with new and more advanced transmission technologies. So during the life of the system, by doing upgrades, you can expand or extend the capacity of the system.
I'd like to also just highlight that we've seen real life evidence of this in the GlobeNet network. ASN supplied the original GlobeNet system back around 2000. The transmission at that time was 10 gigabit. Everybody was thinking that was quite a big improvement from the 2.5 gig that was previous to that. Now we're even on that system. We're talking 100 gig transmission and multi-terabits worth of capacity on each fiber pair. So we don't expect any difference with the Malbec cable system. As Philippe already mentioned, at day one, we're already at 18 terabits per fiber pair, and we expect it to just go much higher from there.
Excellent. Diana, just jumping back to you now, how do you guarantee the security and redundancy of systems?
Right, so we have a career of 17 years plus building networks in the region and integrating networks as well. We are the only provider that offers a protected ring in the Atlantic. So that alone gives you evidence that we consider redundancy and security of our network prime, but also in the systems that we just talked about, right? So we're building from the cable landing stations to the new POPs, and in both Buenos Aires and Sao Paulo, we're making sure that we have protected and diversity stations to the POPs. That for us is always key. And going even further, if we have to lease third-party connectivity in the region, we always make sure that it is protected. Philippe can attest to us never selling anything in the region that is not fully redundant and protected. So security for us is key. And on top of that, we do offer the DDoS protection for our customers that want to extend that out to their enterprise financial district customers. That's also very important for us, and it's a great layered product to add data security.
Thank you. And Philippe, is there any risk of CLS flooding?
So no, we in the design of the CLS, we took this into account, especially in Las Toninas. The CLS in Las Toninas is located about 2 kilometers from the shore. But the CLS is a modular type of CLS, so we assemble modules into a CLS, and the modules are placed on some piers, which are about 1 meter above the ground. And we did the same design in Rio, in Praia Grande, where the likelihood of flooding is much less.
Excellent. And is GlobeNet providing subsea access to other countries in South America?
So that's something that we are looking into, and maybe strategically we are always looking for opportunities to address new market and new geography. So it's a possibility.
Well, I think it's also important to note that you're building upon an existing network that's already landing both in Venezuela and Colombia.
Thank you, Richard. Now we have another question just coming through. You talked about how Malbec is an open system and how that allows you to have an open choice of the technology you'll use to light it. What do you look for when choosing the transmission equipment to light such a kind of system?
So we try to optimize the spectrum efficiency of the cable system. So we pick transmission technologies which would allow us to optimize the capacity on the system. In this particular example of Malbec, we had several options that we were considering, and it comes down really to performance and price.
Thank you. And another question just coming in now for Diana. Is GlobeNet providing subsea access to other countries in South America? Sorry, no, someone's posted that one twice. Fantastic. Well, thank you very much, everybody, for your input. That's definitely all the questions that we're able to answer. Any closing comments before we wrap up the session today?
Well, I would like to thank GlobeNet for inviting me to support this, and also allow me to go into my closet and take out a jacket that I haven't been seeing for the past few months because of the COVID situation. So thank you very much, GlobeNet.
Thank you so much to all our panelists today. And that brings us to the end of today's session on the Malbec subsea cable system. Thank you also to our audience for joining, and also to our presenters, Diana, Philippe, and Richard. This session will be available via capacitymedia.com. For any questions, you can reach our speakers via LinkedIn or via the email addresses online. Thank you so much. Bye-bye.
Thank you all.
Bye.
Bye-bye.